6.4 Matrix Inversion. In this section, we are going to learn how to find the inverse of a square matrix using the row operations. Solve the system of equations by matrix inversion. Inverse of a matrix. If A and B, they are n by n matrices, I is the n by n identity matrix, and when matrix A times B is equal matrix B times A is equal identity. Now n by n matrix, we call this is a square matrix. A matrix has the inverse if and only if the matrix is a square matrix. If your matrix is 2 by 3 or 1 by 2, in that case, you won't be able to find the inverse. So only a square matrix that will have the inverse. For example, 2 by 2, this is a square matrix. 3 by 3, 4 by 4. Only the square matrix has the inverse. Now with a 2 by 2, identity is 1, 0, 0, 1. When the matrix is a 3 by 3 matrix, the identity matrix would be 1, 0, 0, 0, 1, 0, 0, 0, 1. So they are paired with the matrix size it has. A 2 by 2, you will have a 2 by 2 identity. 3 by 3, you will have the 3 by 3 identity. When two matrices multiply, the result getting an identity matrix, we call that is multiplicative inverses. So the matrix A is the inverse of B, and the B is the inverse of A. Show the A and B, they are inverse. So according to the multiplicative inverses rule, we can multiply A and B, and then multiply B and A. As long as the result, either direction, we will get an identity matrix. Then that will prove A and B, they are inverse. Now A, as here you can see, is a 3 by 3. B is a 3 by 3 as well. So that means the identity matrix of this one, we will have a 3 by 3 identity. So this product is 2. We start from A times B first. So when I have the matrix A multiplied with the matrix B, we use the row of matrix A to multiply the column on the matrix B. So we will have the row 1, column 1. So we look at the example here. So I have the 1 multiplied by -3 plus 1 multiplied by 4 plus 0 multiplied by -2. So this will be the row 1, column 1. Now we move to the row 1, column 2. So I use the same row 1 value, 1 multiplied by column 2. So 1 multiplied by 1 plus 1 multiplied by -1 plus 0 multiplied by 1. Now we do the row 1, column 3. So I will have 1 multiplied by 0 plus 1 multiplied by 0 plus 0 multiplied by -1. And then you process the same way. Move to the row 2, column 1, row 2, column 2, row 2, column 3. And then you do the row 3, column 1, row 3, column 2, and the row 3, column 3. Then you clean up each of the row column form here. So as a result, it has identity matrix because on the negative diagonal direction, I get all the number, they are 1. The remaining number, they are 0. So this is a 3 by 3 identity. So when we prove the A times B, we get an identity matrix. Now we do the other way around. We use the matrix B, multiply matrix A. So same way, row 1, column 1, row 1, column 2, row 1, column 3. And then row 2, column 1, row 2, column 2. So process the same procedure. So now, the result, when you multiply matrix A to matrix B, it gives us the same result with the identity matrix. So that means these two matrices, they are inverse. How do we find the inverse of a square matrix using the row operation? Most of the time, we use the formula to finding the inverse of a 2 by 2 matrix when you have the 2 by 2. But that formula only can go with the 2 by 2. When we have the 3 by 3, 4 by 4, we can use the row operation to process of finding the inverse. Or you can use the calculate. And here I'm going to show you do the 2 by 2 manually, how to find the inverse. And when you have the 3 by 3, we'll go with the calculate. And before we move on to solve for a 2 by 2 inverse, let's read this one. A matrix that has an inverse, we call that is a non-singular matrix. And we also say that is an invertible. If the matrix has no inverse, then it isn't a singular matrix, and then it's non-invertible. So recognize these two differences. When the matrix has an inverse, we call that is a non-singular, and it is invertible. When it's not inverse, then we call that a singular matrix, and then it's non-invertible. So we take a look at this example. We have a 2 by 2 matrix here. So matrix A is 2 by 2. This is a square matrix. That means I can find the inverse. So how can we find the inverse? By using the row operation. The idea is we have the matrix A stay on the left hand side. So this 2 by 2, right? 1, 3, 2, negative 1. This is the part from your matrix A. Now, on the right hand side of the vertical bar here, this is the identity matrix. So I put a 1, 0, 0, 1. Now, we want to make the change on the left hand side of the box here. They turn to the identity matrix. And then the right hand side, whatever it has as a result, that would be the inverse of the matrix A. So by the end, we are looking for 1, 0, 0, 1. And then the inverse of the matrix A would be the right hand side portion here. So how can we convert from this board into the identity matrix? We do that column by column. Okay. So now the idea is we want to keep this number as 1. We want to keep this number is 1 as well. And then the remaining 2 turn to the 0. So we process the work column by column. If I keep this row is a row 1, this is a row 2. Now the row 1, the first entry on the row 1 is a 1. This is perfect, right? We want to keep it. The first entry on the row 2 is not a 1, it's 2. So we want to make this number turn to a 0. So how can I make the 2 turn to the 0? I mean, we need to minus 2, right? And we use this point, we use this 1 as a pivot to manipulate a number, to multiply with a number, and that number will be able to get rid of the 2. So let me show you the work. The idea is we want to multiply negative 2 to the row 1. So let me write down this way. We multiply row 1 with negative 2. And that's, when you multiply negative 2 to the row 1, that means you do that for the entire row. Each element on the row 1, you have to multiply negative 2 into it. So row 1 multiplied by negative 2, and then you use the result of here to combine with the row 2. Whatever you have here, it go back to the row 2. Alright, so let me show you the work here. When we have the row 1 multiplied by row 2, when we have the row 1 multiplied by negative 2, so this element 1 turn to the negative 2. 3 multiplied by negative 2, you turn to the negative 6. 1 multiplied by negative 2, you get a negative 2. 0 multiplied by negative 2, you get a 0. Now we combine with the row 2, right? So the row 2 is 2, negative 1, 0, and a 1. Now we add these 2. So you turn to the 0, negative 7, negative 2, and a 1. So whatever result we have here, we keep this result on the row 2. So this will be your new row 2. Now we record the new row 2 on the next step. So I have the row 2 here. This is the row 2. So this will be your new row 2. So now the new row 2, we record with 0, negative 7, negative 2, and a 1. How about row 1? Row 1, we just copy down the row 1, whatever we have from the previous step here. So 1, 3, 1, 0. Now as here you can see, on the column 1, we have the 1, 0. Right? That's what we want. So we are done the column 1. Now we move to the column 2. According to the identity matrix, on your column 2, we want to keep this element is 1. But now I have negative 7. How can I make the negative 7 turn to the 1? I mean, we have to divide by row 2 with negative 7. And then, whatever you have, it will turn to the new row 2. Let me write down this way. Probably it's easier for you to see it. So the row 2, we have 0, negative 7, 0, negative 7, negative 2, and a 1. 0 divided by negative 7, you keep the 0. Negative 7 divided by 7, you turn to the 1. Negative 2 divided by negative 7, you turn to the 2 over 7. 1 divided by negative 7, you turn to the negative 1 over 7. Now, the result here is your new row 2. So we do the next step.